it's running.
Okay. Hi everybody, thank you for coming out to the 10th libsurvive live stream. As I've said in my summary video, over the last couple, it's the libsurvive May 2017 update video, which I shot in infrared. We came a long way, but boy oh boy is the Vive a heck of a lot more complicated than we were expecting. These live streams have, well, we've had a lot of fun with them, but it's a lot more work than I was expecting. So, any rate, so this live stream we're going to be doing something a little bit different than I had in 1 through 8. This one's going to be mostly surrounding wanting to make this. Oh, I can't really move it. Wanting to make this right here, a board with an ESP8266 on it. Talk to this right here, a board with a little TIA on it. TIA being a transimpedance amplifier, and this right here is a little photodiode, and getting this to talk to an ESP8266 to see what all we can do with it. But we also have right here David Chapman, who's going to be working more with the OSX port and more algorithm work, and my brother over here, Andrew, but I don't know. I have yet to be able to entice him to work on any libsurvive work, which is sad because he's a math PhD candidate. So, come on, Andrew. Anyway, oh, is Mom in the chat? Is that what he's saying? Oh, anyway, I guess a little bit of updates. We really have come a good bit of a ways. A lot of stuff's been covered on the README file in the main libsurvive URL here. So I actually go a lot more into the architecture that we have going so far, a little bit more of the introduction, and a much more in-depth discussion of exactly what the libsurvive architecture is, how it works, and I've color-coded the different components for how done they are. I guess the only thing that's a little bit different is the IMU calibration right here. This is no longer red, this is a little bit more like yellow or green because Josh Allen was able to kind of get that underway. We don't yet do runtime calibration, which we're going to need to do because the IMUs, at least in the headset as I was playing with it, seemed to drift a little bit. So that's not really that bad. Andrew, can you ban or put that user in timeout? So we have the different components. So far we have several competing posers, and posers are things that take angles from the lighthouses effectively, or from the lighthouse's point of view, and then try to figure out where the objects are based on it. And that's, I guess, probably the most diverse type of coding that we have going on right now. So I have my original one that I was working with from like livestream 2, 3, 4, 5, which was just awful. And we have Dave's, that's this Dave who's right here, his, that Dave, who wrote his own, which is using affine transformations. But we don't really know whose poser is going to win this poser war, so to speak, because Octavio and MW Turvey both have pretty interesting things going for their posers. So we have that. We have disambiguators, and these are things that take the random light pulse times and try to figure out which lighthouse they came from and decode them to some degree. But you get angles from these light pulses, which get fed into the posers, and really there's only two competing ones for that. There's one that I wrote, which I'm still liking, but there's also one that MW Turvey wrote, which does seem much more robust. So there may be a trade-off there where some systems are going to end up using mine, some are going to end up using MW Turvey's. Specifically for embedded systems, I'm pretty sure mine is going to be the winner, and for desktop systems, I'm pretty sure MW Turvey's is going to be the winner. So there's really no reason to keep both. The only one that we have kind of given up on was I'm sorry if you're watching right now, JPICHT. We did eventually kind of do away with yours because both of ours superseded it. But you're more than welcome to come back and write a better poser than both, or a better disambiguator than both of us. The other thing is right now, and hopefully that'll be changing over the next 2 live streams, we only support one driver, and a driver is something that takes in hardware, something that'll talk to specifically right now the Vive and be able to get this information. But hopefully we'll be able to get a little bit more in. And then we also only have one OOTX decoder, but I'm pretty sure we only need one because OOTX is a pretty basic system for decoding, and that was written by Josh Allen. Go a little bit more into some of the other details, but yeah, if you haven't already read through the GitHub README file, totally do that. That's where most of this good stuff is. The other thing is, if you haven't joined Discord, the Discord invite app link thing is on the GitHub repo page for libsurvive. Sorry, what does he say? Oh, hi, it's Octavio. What is Matthias? Is this guy genius? Oh, I am a computer engineer. And compiles for me a couple of times. It complained. Oh, so did it open up a window on OS X?
Yes, it did.
Okay, so OS X works now.
It works.
Okay. Somebody was having issues with the OS X build of libsurvive. It looks like it's fine now.
It's fine on my computer. That doesn't mean that it's fine on someone else's.
Okay. So if you're somebody who is using libsurvive on OS X, give it a shot with the current code base. I know like I made some minor changes and some other people made some, so maybe we accidentally fixed it in the in-between.
Right, but maybe I just don't know what to look for that's wrong. So.
That's possible.
Or maybe my computer has something that the other one doesn't or something. So it would be good to just get a better idea exactly what the problem is.
Yeah, so if you're out there and you're watching this and you're on, specifically right now we're trying to get OS X a little bit more up to snuff, if you can go try getting libsurvive and building it, give it a shot and tell us if you're having trouble, and if you are having trouble, what trouble you're having. So that would be really helpful to us to get moving. So I guess now we're 10 minutes in. It's time to discuss what I was doing over the last couple live streams, and that is designing a new TIA circuit. Oh, did you want to say something?
No.
Okay. A new TIA circuit for myself. So this specifically is for a different project I want to do. I did end up getting, I don't know where it is. I'm going to see a white box somewhere. It's still sealed. No, it's flat. Okay, I don't know where it is. I ended up getting a box from Triad Semi. Oh, there it is. A box from Triad Semi. Specifically, these are the 10 of the little doohickeys that will read light from the lighthouses and convert it into a digital signal from an analog one using all of the complicated stuff that Valve does. I haven't actually opened this box yet because I've been so busy trying my own thing, and that's really not the right way to do it. I know it's hypocritical for me to say this, but what you probably should do is start with something you know works and then work from there, whereas I just kind of wanted to have fun, so I started in the wrong direction. So if you were actually going to try to do this, you should totally work with something that works and then build your own stuff, but I'm going to have fun with it. So my approach is a little bit different than Valve's when it came to wanting to design my own system. What I really wanted to do was something that could actually look at the individual pulses at 1.8 megahertz. And the way I chose to do that was using something called a transimpedance amplifier. And what this does is it allows you to reverse bias the photodiode. And by reverse biasing it, it reduces the capacitance across the diode significantly. I'm going to bring up the data sheet for this photodiode. So one of the things you run into is that if there's a lot of capacitance on the photodiode itself, it'll respond very, very slowly. But if you take the positive edge, actually here I'll show you my schematic, if you take the positive edge of that photodiode, sorry, negative edge right here, and you drag it positive. So I have a resistor here that I'm sorry, that's the wrong way. Oh, it will. Okay. So and I take that it's going to be pulled positive. Then it makes it so that there's this. It's called a reverse bias on the photodiode. And when you increase the voltage of that reverse bias, I'm actually around maybe 2-3 volts. That capacitance is much lower, so you can end up responding very, very quickly to changes. So like pulses of light. So I take that and I pipe that into my op amp in a configuration where it's a TIA. Now you might be looking at the schematic and you see a little LED down here, and this is actually part of the circuit. This little LED right here is what creates the 3 volts or 2.5 volts that I use to, oh gosh, it is in English, but I will admit, I guess it is a little confusing. I'll try to simplify it a little bit more. I have a voltage reference, and that's created by this blue LED. And so the voltage on VG1 is about 2.5 volts. And so that's where I really try to center my signal. So what I can do right now is I can plug up, ooh, that's kind of hard to see. Let's see, is there any way of getting that closer maybe? I guess maybe you can see it. So there's a little Sele, and so I can hook that up here, and I can probe out that little bit right there. So what I'm going to try to do, if I can find a thing here, is I'm going to go look at the voltage that I'm trying to reverse bias the photodiode. And what this does right here is, let's see, yep, there it is. So I'm reverse biasing 2.5 volts. And so what that means is that's going to be where the goal is to get the voltage on the opposite side of the TIA. I've used TIA a fair bit, and if you're unfamiliar with what a TIA is, I really recommend reading this Wikipedia page on the transimpedance amplifier. But basically what it does is it allows you to convert the current that's induced inside of the photodiode into a voltage on the other side. And this is really useful because it allows you to detect very, very small changes in current and convert them into voltage. Now, if you have a voltage that you're trying to measure on the diode, it means it has to push against it, against the capacitance, this thing right here, the CI. So it would mean that it would be very slow. But because the TIA works in current mode, that voltage change should be insignificant. So there's a few other details with it. They recommend using a CF capacitor and all of that. But there's this funny thing that goes on if you skip that. If you remove that CF capacitor, it totally breaks the whole system, but in a really interesting way. So the current to voltage gain actually goes sky high at a certain point before it drops off. And conveniently, coincidentally I guess I should say, for this op amp I found, this FI, this mark right here, is almost exactly 1.8 megahertz, which is exactly what the Vive system uses for transmitting. So I inadvertently, by removing some parts of my system, really improved the quality of well, the whole thing. So I actually removed this capacitor completely. So then I bump it over to the other side of this op amp and just take that lower voltage and bump it up. So what we can do is we can look at that first stage. I'm going to see if I can get the sensor visible. So right now I'm going to read in the first stage of it. So I'm going to probe out this wire right here. So this is the direct output from the, it's barely visible. Ooh, that's wrong. It's not reading anything. Let's try that. Nope, still can barely see it. Oh, hey, that's neat. You can kind of see it over here. Okay. So you can actually see a very small swing, so 0.1 little bit under 0.5 volt swing. And this looks right here like a sync pulse from the lighthouse. If we go a little bit further, let's see, let's scoot out some. So we see the sync pulse from the lighthouse that's directly in front of me, and a sync pulse which is from a lighthouse about 5.5 meters away. So you can see that the system can detect those light pulses. Very, very dimly though, and it's just barely able to pick them up. And you can see that this can barely see this right here. This right here is actually a sweep pulse coming from the laser. So it's working, but it's, boy oh boy, is it really hard to see. So what I do is I take that out and I pipe it over here, and this has changed a little bit. This circuit now has, actually I guess I should show you guys what the current circuit looks like. David, if you want, you can take that chair, which is, I think you liked that one better. You just put the box on the ground.
Oh, no, I think I'm good here for a little while.
Okay.
Yeah, when you get a chance, I have a couple questions about the calibrate code. Okay,
what I'll do is I'll demonstrate this, and we'll go over to the questions on the calibrate code. Actually, is it something I could pull open on my screen?
Take your time.
Okay, so this is the current design, and so what does this look like right here? I have a capacitor and a resistor. It's a high-pass filter, and this right here is an op-amp that's going to boost that voltage and have a reference voltage right here. And so, actually, yeah, as PACCC points out, you can take that really small voltage on this side of the TSV 992 and use the other side of it to boost it. So we'll do that right now. So instead of probing that one pin, I'm going to probe the output here. And let's go record that. Let's get it visible to the lighthouse, and I'm going to record and stop. So now we can see really clearly this right here. Oof, huge wave, crystal clear. I mean, like, look at this signal. It's positive 2.6 to 0.6 volts. Now, granted, that lighthouse is only 2 meters away. The other thing that's kind of neat is that once we get that, you see this ringing at the end, which might hurt us, but that ringing is because this filter is so tight around 1.8 megahertz that we get that ringing going on. So this may not work in the long run, but certainly worth it for right now to give it a shot. And if we scroll over a little bit, so that's probably from the other lighthouse, but right here, this is a sweep pulse from the lighthouse directly in front of us. So you can see that really clearly. And so the goal is to take this, set some threshold to it, and see if I can use just the regular inputs on the ESP8266 without a comparator or anything, and just shove this analog signal into the ESP8266 and see what we can see. I really can't wait to check that out. One of the other neat things is if the ESP8266 sees more ones than zeros or zeros than ones, I can actually take this, a trimmer, it's a little tweaker screwdriver thing, and I can change that voltage until we can get a signal that looks like the signal that we're after. So yeah, just so you guys see, this will be the signal that I'm going to be working with today on the ESP8266, and I'll see if I can actually get the signal out and be able to back it out and get it digitally on this little $2 microcontroller.
Yeah, if you guys want food, we've got some over here.
Yeah, David, if you're interested, we just went out, so.
Great.
Okay, thank you, Adam. Okay, so David has some questions now. Do you want to try to VNC in?
VNC?
Yeah. Remember how I can VNC to you?
Oh, right, yeah.
Do you know your IP address? Unless you don't want to share screens, that's okay.
No.
I can bring open the code here.
Okay.
So you had a question about what aspect?
Yeah, so we should be running calibrate and not calibrate client.
Calibrate client. What was
Well,
calibrate
what's the
client?
difference between calibrate and calibrate client?
I don't know what calibrate client even is. I haven't run it.
Oh, I see.
I mean, maybe I have and I've just forgotten. Calibrate.c, calibrate client.c. I don't think I've ever run calibrate client.c.
Okay. When I look at calibrate.c,
Okay.
I just want to make sure that it's the same in the survive thread. It's running survive poll. And survive poll, I guess, does everything that needs to be done with regard to reading from the survive data?
Yes, survive poll, so what Dave's referring to is this down here, this survive poll command. That's what actually goes and tells libsurvive to go update everything and process out data and run all of the callbacks.
All right, so because of that, there aren't any. So this comment here inside the while loop, we don't have to do anything inside of the loop.
No, we really don't.
Additional. Okay.
No, you could if you want, but you don't have to.
Okay.
Right now, I just treat this as like a loop that just runs continuously.
Okay. All right, thanks. That's the only question I had.
Oh, okay. So does it actually run on the OS X?
It runs, but you know the thing is that it runs, but what I'm not sure about is whether it's running correctly. There's a difference between it compiles and it opens a window and versus getting good data. So I think what might be going on is that it's running, but it's not actually getting the data.
Can you run it real quick? And
yeah, let me show you. So if I run calibrate here, then it opens the window, but it doesn't seem to be advancing. So I'm wondering what might be going on with that. I'm going to put some probes in survive poll and see whether that's actually refreshing or if it's getting stuck.
You probably would be better off checking in run /data recorder.
Data recorder, not calibrate? Okay.
Nope. Although for me, data recorder is not going to work because I don't have a Vive hooked up. But
of course.
For David, it should work.
That crashes.
Ooh.
Okay.
That sounds like something we can start debugging.
All right. All right. Well, let me put that on the Discord. I finally know what's wrong with Mac.
Okay.
So now.
Okay. So I guess right now while David works, I mean, has anybody else out there like actually tried building this or working with it or anything else in Windows or Linux or Mac? And if so, have you guys been doing well? Have you guys been having problems? What's been going on with that? In the meantime, while you guys respond, I'm going to just take a look at this a little bit more and aim this around the room a little bit and try to get a feel for what this signal is going to look like. Wow, that's really weak. It's not going to get picked up at all. It might get picked up. So this pulse right here is from the other side of the room, and it goes from 1.8 to 1.3, and I don't think that's big enough to be picked up by the ESP8266's input. I do think these will. That's a pulse from the lighthouse in front of me. I don't think for this live stream you'll be able to do very much without a Vive. Previous live streams I could stream data from the Vive directly. Yeah, no, I really think you guys are going to have to start buying the Vive. So I think that this data actually looks pretty good. Maybe I just want to pipe it in and see what happens. So I have this here. I have my little ESP localizer, which you guys can buy. If you guys want to buy this little board I'm working with, you can. Yeah, Christoph, I could, but it would take more hardware. I want to see if I can get away with this for just a few cents. I can't really talk about yet why I'm trying to do this so absurdly cheaply, but I do have a purpose behind it, and if I succeed, then you guys can actually see the purpose. If I fail, I can't tell you what it was. It's for another project that's not even my project. So let's see here. Boop, close that. So in here. Oh, that's right. I have to look up ESP localizer pinout. So I'm going to hook into ground, which is down here. And I'm going to plug the other end into DAT, which is 3 from the 3rd from the top. So that's on the MO pin. MISO, master out. Wait, no. MO. Oh yeah, MOSI. Okay, that's right. Got it. Okay, so these are now hooked up to the ESP. Let's see how this works. Actually, I feel like I should get the camera closer. Can I do that? See, let's get the camera pointed on this. Ah, gorgeous. That looks good. So you guys, if you want to see the close-up here, this is the board with the TIA on it, and this is the ESP localizer board. See, it's got a little ESP8266 on it. And we're going to see if we can see some pulses and sweeps and stuff. Let's see, can I use this box here maybe? Ah, gorgeous. Hopefully that's going to be visible. Let's make sure that this is all still visible. Yeah, it looks pretty clear. That is one sync pulse or sweep pulse, and that should be able to be picked up by the ESP. And here is the other sync pulse or sweep pulse. And I don't think the other lighthouse is going to be able to be visible there. Huh. Okay. Whoa! 899 euros for a Vive? That's ridiculous. I mean, euros are still more valuable than US dollars, right? Oh man. That's rough. Anyway. So I send out an X every frame. Okay. Probably don't need to do that. If you have any questions about anything, Dave, just give me a heads up.
No, right now I'm trying to trace through some OSX issues.
Okay.
It looks like LibNet is having different issues with the OSX board. We're wondering whether it might have to do with the version of live USB. But, right now,
you should be able to switch to Signal 11.
Signal 11?
If you look in the makefile, there's a thing called HID API.
We'll look at the makefile, because I'm not having a problem with it, but maybe that has something to do with it.
Okay.
Because he's having a live USB problem, but I'm not.
Sweet. That means that these dots are being executed from the interrupt, the I2S interrupt. Let's do only one dot. Let's see how fast that interrupt is being fired. So we see a lot of those dots. I can type in seer term pipe PV, and what this will do, actually I should probably pipe the rest to null. And so what this is going to do... Hello? Okay, so it looks like the... Oh boy, 11.3 kilobytes a second. Coincidentally, that is also the speed of 115.2, so this is probably dropping off the end of a buffer. Static int k. K++. If k equals 100, then we're on our 100th one. K equals 0. Okay. So what I just did is I made it so it's only every 100th interrupt does it print a dot. Okay, this looks a little bit more... I don't know what those X's are. Let's just see. It says 400 bytes per second. So that sounds about right. So let's see, what are our buffer sizes? So that's 32 bytes times 32 bits. 1024 times, sorry, the 40,000 divided by 1024. And then divided by 100. So 390. I don't know why it's getting 400 though. Maybe it's that X. What is that X doing? Shouldn't happen there. Oh, I undid my changes. I don't know why I undid my changes. Oops, did not mean to do that. Let's try burning it again. Beautiful. Okay, let's see how many periods per second this is. 390. Golden. Look at that. Okay, so that means the interrupt is firing 39,000 times per second, which is good. And each one of those times, it should have 1024 bytes of data. I think I want to sample faster, though. So let's just see if we can get the interrupt firing up to 80 megahertz, you know, for funsies. No, it does not work. Don't know why, though. I'll have to figure that out. Actually, I have another idea. Let's overclock the ESP8266. So, Christoph, thankfully you're here. I can actually thank you for this. Christoph has been the one to formalize a lot of the stuff that I did with ESP8266 into a really nice kind of thing on top of the SDK. And part of that was to then also import a known good SDK, a no-OS SDK from Espressif, which has a couple of libraries that they specifically sent me for various things, which they said I could repost, so I'm not breaking the rules here. So where is it? It's user interface.h. Update CPU frequency 160. So what this does is, instead of having to go dig around trying to find the right libraries for everything all the time, you can just go here and it just works. So thank you so much, Christoph, for making this all nice and formal. Still not working. That's not good. As to why it's not working, I'm not sure. Ben Jackson, no, the ESP does not, but that's okay because what you can do is you can iterate through 32 bits at a time and you can say, is this value not 0? And if it's not 0, then you know that something happened in there. And if you're iterating in a loop that fast, it's going to be pretty easy to find any data. I did the same trick in the ESP Ethernet. And so in here, what I do is I can find that loop somewhere in here. Here. So what you can do to speed along really fast is just fly through the data and look for anything that's not an FFFF or 000. And if you find something that's not that, then you know that something happened and you can go investigate it further. As far as I'm aware, we're probably not going to have that much noise in this system, so it shouldn't really be that much of a burden on the ESP to go find specifically these bits. So it should be okay. But as to why this isn't working, I don't know. Let's try this just in case. Oh, hey, check that out. See, is that still 400? No, still 390 though. Something's up with that. I don't think I've ever really done any projects where I've been trying to read the I2S port at that speed. I've always been writing to it, so maybe the ESP can't read at 80 megahertz. That would be a real bummer. That would be really, that would rain on my parade. But on the other hand, it does mean that's a lot less data I have to go filter through to figure out what's going on, so maybe it's not that bad. I really don't want to have that pin if I can avoid it. Christoph, what are you referring to with not self-serving at all? I mean, I detect sarcasm in there, but I'm not sure what you're referring to. Yeah, I guess 40 would be fine. I can try to find that out later, because I thought that Duplex I2S could handle 80 megahertz. Let me see if I have other copies online. I think that's 4. This is 2 and 1. I don't know what the div has to do with it. Yeah, I get that I don't need the extra speed, but I don't want it to be good enough. I want it to be awesome. But I guess I'm going to have to give up shortly here and just get moving again. We can play with that later, I guess. As to why that doesn't work, though. Maybe it's that you can only do 1/2 of the DMA engine at 80 or both halves at 40. I can't remember exactly. But whatever, if we do this, that means I get both halves of the DMA engine if I want. Okay, yeah, we'll just do 40 megahertz for today, and then we'll go from there for some other time. Aww. Thanks, whoever wrote that. Yeah, I don't know. Okay. Whatever, we have data coming in. That's what I care about most. Okay. I guess what I want to do next is I want to iterate through all of the data here, and if I get something that's non-zero, I'll print it out. User, let's call it, what is OOTX the name of the generic name for those light emissions? Or is that just the name of the protocol that lives on top of the light emissions? I'm just going to call it lighthouse process. We have sync pulses and sweep pulses. What's the generic name for both sync and sweep? Okay, Christoph, you're not the janitor. You're the one that's like, hey, by the way, this totally isn't working this way. Do it this way. You're the one who like figured out the submodules and all of that. And I'm like, I have no idea what submodules are. I'm not going to deal with any of this. I don't know how Git works. Okay, I don't know if anybody actually knows how Git works, but I mean, maybe Linus Torvalds did. But, yeah, I don't know. Size words.
It would be really cool if Git made you type get up. Just
get up?
Get up, yeah. But it doesn't work that way. You have to get pull.
Optical data, okay. Optical data, lighthouse decode. I guess we can call it optical decode. I like the word lighthouse. We'll just do lighthouse. Oh, you know what? I remember what the deal was with the... We don't need to worry about it now because it would take me about 30 minutes to implement. But it has to do with the way that the DMA descriptors are set up. There is a way of doing 80 megahertz read. I remember that now. But that would be a pain to do live, so I'm not going to do it live. We're just going to go with 40 megahertz for now. I don't know how I forgot about that until right now. Copy this over here, and I'm going to go call this function from i2sduplex.c. I believe I'm going to pass in data and that, and I think that's what I do. Data, where's data defined here? That's what I need. Finish descriptor. Yeah, that's right. Okay, so we're getting the descriptor that just completed its action, and we're going to be operating on that. Okay, yes, that sounds right. Delete all this junk. I don't think that's needed anymore. I think there's another way around that. You can try throwing that in, maybe. Just I did that. Let's not make file. Badoo, add in, user, lighthouse, decode, let's see. From the ISR, it's a bold move, Cotton. Let's see if it... What is that from? Is that a meme? It's a bold move, Cotton? Bold move, comma, Cotton. Yes, I know, but the ESP8266 might let me get away with it. We'll see if that's the case. Actually, I forgot. Maybe... How did I do it on ESP Ethernet? Is that... I think I did it from the ISR itself. Let's see. Did I do it from the ISR? I don't even see the ISR in here. Oh, here it is. No, it looks like I did not operate from within the interrupt handler. Oh, no, right here. Does that do processing, or does it just throw it on a buffer and then I process it later? Ha! Nope, looks like I handle everything from inside the ISR, so if it worked for ESP Ethernet, it should work here. I hope. Whatever. I don't think... Oh, I do need it. What is that from? That is from... this file. Let's make sure we're getting data. Oh yeah, look at that. 32s. Lots of 32s. .383, yeah, okay, so it's still getting them all. So it says it's 32 words, which is good. Do I really want to process that little at a time? Let's see here. So what would that work out to? I have a sweep pulse right here. 32 words at 40... Let's divide by 32 words, divide by 32 bits per word is 39 kilohertz, so... 25 microseconds, so yeah, that should actually do it. Yeah, 25 microseconds. So this looks like the amount of data I would be receiving in one thing. It's probably fine. It's probably good. It is an interrupt. So, yeah, Josh, I know, but it's so convenient to just throw all the code in there instead of buffering it and doing other stuff. And it also takes, I don't have to allocate buffers and set up ring buffers and everything else. I just have this thing here which can spin around and around. If it's a problem, though, I definitely will pull it out of the interrupt handler. But really, the ESP8266 has hardware to handle just about everything, all the way down to the Wi-Fi. Like the ESP8266 can actually ACK Wi-Fi messages without using an interrupt inside the processor. The processor can be completely dead, and it can still be mostly, for the part, connected to the Wi-Fi. Yeah, the AVR is a very different world. Things can just fall apart really fast if you're not careful there. But on the ESP8266, there's so much stuff that's handled in hardware. It's really not an issue. So let's run this and see if we get any non-zero data when I touch the port. That's concerning. That should not be happening. Let's short this out. Oh wait, that should be happening. I think that should be happening. Maybe? Should it be happening? Maybe tweak your screwdriver. Did you see my backpack, Andrew? That's Dave's. That's yours. Can you check on the post? Actually. It's down there. I would imagine the processor is rebooting because it is being significantly overloaded in the ISR right now, which is understandable. Ah, gorgeous. So as I'm rotating this tweaker screwdriver, it goes from all of the data being gone. So let's see what this looks like in the logic analyzer. So right now everything is at 0.2 volts.
Do you mind if I make some noise? Cookies.
Let
me know when I do it.
Okay. So this looks like, yeah, I see why none of that's coming through. Let's up it a little bit. So now just a little bit of data is coming through. No. So it looks like about 1.6 volts is where data starts. Whoop. Let's check this. Now all the packets are about 1.6 volts. So let's see. So now we're getting bigger and bigger. And now most of the data is FFs, which is to be expected. I think I want to arrange it so most of the data will be zeros. And we'll see what we're actually getting here. Oops. die. Okay.
When you get a chance, I found an error message.
Okay.
And I want to know what that means, if this is bad or good.
Okay.
It grabs the device, but it hit this message. Could not get survive config data for device.
That means you do not have privileges as the user to configure that part of it.
So I just need to run a super user.
Yeah.
Okay. That's
Yeah,
easy
that
enough.
should only happen if you're running with live USB, though. Are you running with live USB,
I
or did you
believe
switch
so.
to Signal 11? Okay. Yeah, Adam, you can make noise. Alright. I guess that thing's pretty quick. Okay. So I just unplugged the one of the lighthouses, so we should be getting much less data right now. Let's see. Let's see what that looks like. How many people are watching?
4.
How much?
88.
Oh wow. Okay. Yeah. That's how many people are watching and one person leaves. Okay. So that looks kind of interesting.
Yeah, it looks like I still got that issue as running this super user.
Hmm.
So what's the name of the other?
HID API. If you look in the make file for something called HID API, you can try that.
I'll give that a try. Oh
Okay.
no, it looks like it is using HID API.
Oh, this is neat. This looks exactly right. 7FC 1F 38, so that's several bits. So this looks exactly like a bit pattern that we could use. Let's see, so that's 13, 14, 15, 9, 10. Oh, that's weird. That's not what I was expecting to see. Ten, 11, 12, 13, 14. Sorry. 7, 8, 9, 10, 11, 12, 13, 14. Nothing. So that's 1, 2... What is going on there? That pattern is really confusing. 3FE, 1FF8, 7FE7, 1FFF. But I mean, it kind of looks good. But what I'm concerned about is that's this right here. So it goes 9, nothing for a while. Then it goes 1, like tick tick, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 pulses, and then nothing for a bit. What in the world is 13 pulses? Maybe this is. Okay. So I guarantee this isn't 13 pulses. This has got to be like hundreds of pulses. So down here, say 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 20. Oh, you know what? It's underflowing. Ben, why are you so full of good ideas? That's a really good idea. And it's really easy to do. No, it's not really easy to do. It's almost easy to do. I'm gonna have to make an extra cable for that. I'll be right back. I need wire. Oh, solder. What are you up to, Andrew?
Hey, Charles.
Mm-hmm.
I think it's possible that just the devices are outside of the range of the lighthouse, since the lighthouse is pointing that way.
It shouldn't affect the USB.
It shouldn't affect it. But I should at least...
You shouldn't get an error on the USB.
Well, so I'm not getting any errors. I guess what I'm getting is... When you get a chance.
Shoot, no, tell me. Are you just not seeing anything?
I'm just not seeing anything.
Okay, yeah, try moving the lighthouse over here. Or the headset over here.
So it's going to be working on this lighthouse and not the other one?
Correct.
Okay.
Oh, you know what? Depending on the disambiguator, it may not work with just one. Tell you what I'll do. I'll turn on the other one.
That might actually be why I wasn't getting good data, just because it wasn't looking at it.
Depending on the disambiguator, it won't necessarily work with just one lighthouse.
If it's as simple as that, then...
The other lighthouse should be coming up shortly.
Okay, and then will I need to re-angle the lighthouses to try to get them to...
Probably not. It should be able to see them both from there.
Okay.
The lighthouses have a really wide angle of view.
Oh, really? Okay, that makes it easy then.
I say angle of view. It's hard not to talk about lighthouses in terms of cameras. But they are definitely not a camera.
No. It might be that I'm chasing a problem that doesn't exist.
That will not be the first time.
Yeah, I was using Hit API the whole time.
Oh, it was using Hit API, okay.
So maybe it's just not supposed to find the config data.
No, it should be finding config data.
Oh, really? Okay.
But that's interesting that you were using Hit API and it didn't work, so I don't really know what would cause that.
Right, I mean, it wasn't an error, it was a warning, but it didn't get to the end of that config data function.
Right, well that's a problem.
So that's no good.
I mean, I think so. Maybe on some of the hardware it might be okay. Like, do you know, you might want to print out the object's code and see if it's the head mount display or if it's one of the controllers.
I think it was a HMD.
Okay, it should definitely be able to read it then.
Oh, okay. And it looked like it was only trying to read the HMD, because it was only adding one device.
I just realized I made the wrong gender of this thing. What was I thinking? You should be able to see every. Well, no, because you should be able to, even if it doesn't see any lights, it should still be able to pull the configuration.
Yeah, I see. Okay. So is the other lighthouse on? Do you think?
Yes, the other lighthouse. Its light is green, so it should be up. Repeating, hit API has different behavior on Win Linux OS X, like off by 1 arguments resulting on when using report IDs, and different levels of strictness when checking arguments. Whoa. That's concerning. So, this hit API thing might be hard to do on Mac.
Well, let me try. What happens if I remove it from the make file just for a second?
Well, you mean if you use libusb again?
Yeah, just to see
try
what
it.
happens.
Yeah.
Not that I'm suggesting that that's the right way.
Well, I mean, no, that would be really cool if we can get it working on everything. Thank you, Ben, again. Thank you again, Ben. Whatever the English is for that.
That is better.
Okay. Okay, let's take a gander at this. So we're changing that so it has data out. How do you get to the data out? Actually, it might use the same pipe for both. Let's just see what happens if we don't change anything.
So if I disable hit API, then I get the problem that Big Mac got. We're not playing interface 0 lighthouse.
Then run it as root.
I did.
And you can't claim an interface if...
Without hit API.
I'd take a closer look at that function then.
Okay.
I don't know how to debug that on a Mac though.
I'll take a look at it and see what's going on.
Hit API is wonders better than I had expected. I originally saw the guy from Germanium or Granium talking about it, and I was like, what is this trash? And then I started playing with it. I'm like, oh, it actually works somewhat, which is light years better than having to install fake drivers in Windows to talk to your USB devices, which is such a sad thing. Dear Windows, why can I not send control messages as user space programs? That's so sad. That might be the right thing. Zero volts. Oh, the wrong pin, maybe? That's the right pin. Maybe I disabled TX. Actually, you know what I can do? I can just shove that in there. Let's see if we output anything on the I2S bus. The answer is no. Oh, wait a minute. No. Okay, so what's going on here? Why is this not working? Did I do something to disable one of the directions of the I2S bus? 'Cause I do stupid stuff sometimes. Oh. Oh, that's weird. Okay, so I'm able to output on the I2S bus now, but that's not the way I thought it would work. The RX and TX descriptors are separate. How do I output to that? Finish descriptor is that. Oh, that's right. They handle them separately. Maybe we can just fake it out. Something is not right. Interesting, when it only goes up for one split second it does that, but I mean, it's kind of getting what's going on, but it just doesn't look right to me. Something about it's not quite healthy. Hi, Microhex. Somebody says they don't think they've ever heard good things with the Mac OS HID driver, OS X HID driver.
They've never heard any things about it, but you know.
Let's see here, let's measure that. So from here to here, that should be, that's about right, 1 point. It's fine, it's fine. But like, what goes on here? Like, what's up with that? Why did that get broken? It's just busted. Let's look at another one. Let's look down here. Maybe this one will work. Maybe it's just on the byte boundaries that things get kind of hosed up. So the problem is that the I2S bus off the ESP8266 can't quite drive it hard enough to get that really clear. I do wonder what's up with that, though. That's just not quite right. The frequency's right. Everything looks good. Huh. I know what I'll do. Maybe the right answer is to cruise through the data and build a packet. Reset it every time that happens, then periodically print the packet. How long do these things last? This one right here is... that's 94 microseconds. 40 divided by 32. So 128. Let's say 256 words. Well... so that's 256 would be able to hold 204 microseconds. The only problem is you can't send that in a single WebSockets buffer, so that's probably too big. Whatever, let's just go for it. That, and then I'll do extern uint32t lighthouse buffer len. Here, paste that in, mark it off. Okay. So we can read it out. I'm going to have another flag. So I'm going to say that this means 0 equals ready for data, 1 equals receiving data, 2 equals data waiting in packet. Okay.
Question when you have a minute.
Shoot.
Okay. Hid.c.
Mm-hmm.
Are you compiling it indirectly?
Yes.
And there's a different version for Windows, Mac, and Linux?
Yes.
Okay. And I noticed that the hid API has a Git.
It is.
It's in the repository. Look at nested repository, right?
No.
No. Okay.
I just copy and paste the files out.
Copy the pasted the files.
Because they're thankfully...
And is it linking directly to those files, or did you copy it further into your...
Yeah, it's hid-osx.c.
Oh, okay.
And I copied it in.
Okay, thanks.
That's really concerning that they're not all working. Andrew, can you time out that guy?
I see. Okay, thank you.
$300 seconds. Okay. So what I'm doing is I'm setting up a state machine. So right here, the buffer flag, if it's 0, it means that the thing that's receiving this data is ready for more. If it says 1, it means that there's a buffer flowing in at the time, and like it's capturing off the wire at that moment. And because his WebSockets library is slower than mine on the ESP8266, Andy. I wish people would start using faster stuff for this, but I don't know. The other thing is, because the ESP8266, I need to run this. If this is going to work and I'm going to actually use this for its intended purpose, it has to run on the ESP8285. So I figured it's easier to develop everything for the 8266. But no, I'm... people... I really wish they would focus more on speed and less on usability, and I know what a terribly heathenistic thing that is to say. Okay. 8266 and 8285. 8285 has the integrated flash. User main. So now what we can do in user main is periodically read out the data. Oh yeah, no. If you need the ESP32 for anything hardware-wise, use the ESP32. Like, if I had a reason to use the ESP32, I would be using the ESP32. But, in this case, I do specifically need the ESP8266/8285, so I'm using the ESP8266/8285. You know what? I have a better idea. Let's add a custom command. I'm going to add a command in here. Microhex, I've been trying to get Espressif to get me some so I can sell them on eBay. They do not have an availability date for anything other than their internal customers. And I unfortunately am not at the front of the line when it comes to processors I can sell other people. I wish I was, but I'm not. Is it tabs, or I don't know what the right nomenclature for this is. Oops, wrong button. It is tabs. Okay, we'll use tabs. Okay, let's give this a shot. The ESP8285 was not that successful compared to the 8266, I found out, but I think it has more to do with just that the modules weren't there. I don't know. I'm really hoping people start switching over to the ESP8285 because it is so convenient. And it has the extra 2 GPIO pins, so I don't see how anybody could want to stick around on the old one. I guess the 8266 could read from external flash slightly faster than the ESP8285 could read from internal flash, but it's just a marginal change. Oops. Yeah, that was a convenient thing. But for most commercial products, I can't imagine needing upgrading that flash. It just... Okay, come on. You can do it. You can do it. Boop. Oh, op mode 0. That's wrong. I'm gonna factory reset the Wi-Fi settings on this guy, so hopefully I'll be able to connect to it then. Good. Good. I know you guys can't see my Wi-Fi settings, but I am trying to get Linux to identify it. Found it. Now why can't I connect to it? I hope this doesn't kick all you guys off. Did the stream get hosed, or is that fine? Please, hello? You guys still there? Is the stream okay?
It says 73.
What?
It says 73.
Okay, but like my video is still going.
Yeah, your video's still going.
Okay.
Don't you have like a minute of latency?
Let's see this here.
Like half that.
Okay, that looks pretty good. So I can talk to the ESP. Let's bring it up in a browser. What is the command? Make netweb. Custom command, CP, submit. Oh, that's weird. Mode is 0. I unplugged something? No. Let's check. Oh, weird. Let's also quiet that down some. That's really loud. So that's working again. CP. Okay, so it says that, oh, it used the whole room. Huh. Why would it have used all 256 bytes? Oh. Okay, let's run that again. Aha! Good, we have a packet that is 146 sector or whatever unit something's long. Let's see here, what is a good way of transferring that? Suppose do a T and I can just hex encode it. So int k equals 0. K equals K is less than, and this is actually if buffer flag equals 2, and we can do all this stuff. How are things going?
They're going all right. We're making progress. Although somewhat mysteriously, because some of the problems that we had before mysteriously vanished.
Which ones?
Particularly the config data loading. It's now loading the config data just fine. But all I did was change some makefile flags and then change them back, so I don't know. Apparently, if you put the hit API before the other pound define, I don't know why. That doesn't make any sense whatsoever. So,
well, see if you can track it down and get a pull request in.
I'll try to see if I can cause the problem again, but I'm not exactly sure. But I did because I just changed it and changed it back. Now the data recorder is working for VicNet, but it's still not working for me because it's still getting that seg fault. So I'm going to try to track that down and figure out what's going on with that.
Okay. I don't know if you guys could hear Dave. Could you hear Dave?
Oh, we're still trying to...
No, I mean, they didn't say yes or no.
Okay.
So.
Well, there might be a delay, but still trying to solve some Mac OS X issues.
offline, online. Hey, actually, that's really neat. Ha ha ha! That's cool. I can see the whole thing. Oh, wow. Look at this, guys. This is what a packet looks like. That's 3 bits on, many more bits on, many bits on, 1s and 0s. It's so beautiful. Look at that data. I think it's time I make this a little interface so you can see this. Although that's not the right number of characters, is it? Oh, 144, 1153. Hey! It's actually 1152 because of the enter. Divided by 4 is 288 times 2. Yep. Okay, that's neat. So what we're seeing right here is the actual, I guess I have to zoom in so you guys can see it, is the actual data. If I change the size, I can change the alignment. Like, look at that. You just see this repeating pattern. So I guess the other thing I should do is make it so when I read that buffer out, it clears the flag, so I can read another buffer. This is neat. I'm really excited by this. Submit. There's a new buffer. It's got all these nice little waves in it. Oh yeah. Oh yeah. Aw. You got 1, 2, 3, 4, 5, 6, 7, 8. That's good data. Oh, okay. That's a lot cleaner than I was expecting. Let's see what some of these other... Ooh, 3. 5. I wonder what those are from. Let's see if I point at the other lighthouse if I can get some of them. I don't know what that... Although it's the right pattern. That's the other lighthouse! It can see both lighthouses, just barely though. This is cool. Oh, let's make a nice little display for this. I don't care if this isn't part of the core, like what we need to do. This is going to be neat. Let's edit web / page / I think it's an example.js. Let's see, what does that look like? The example tab. This is an example feature found in... Oh, neat. Okay, display info. Cool. Okay, yeah, so I don't know if Christoph is still watching, but he's the one that like took this and made it so like there's a little example button, so I can go put a thing here. So that's what I'll do. I'll go put a thing here that does the thing I want it to do, and every time I click this, it'll get another packet. That'll be fun. That'll be a lot of fun. Okay. Oh, I don't know if I need to voxelize it. So we'll, instead of calling this example, actually, where does init example? Oh, it comes from there. So I can just change that name. Init lighthouse. Unload init lighthouse. Lighthouse. Example. Lighthouse. Example. Lighthouse. Lighthouse. Let's, instead of doing that, click this pull frame. Oh yeah. Christoph, thanks so much for doing this. Info display. So when I do... Whoa, that's wacky. Is that... I guess that's jQuery. I've never done that. Ooh, weird. jQuery syntax is wacky. Okay, so when I click, I say button data, and it will be CP. When I get that data, I put it in there. Let's see if that works. Make net web. Refresh. Lighthouse. Full frame. Yeah! Look at that. That's the lighthouse on the other side of the room. Well, that's concerning that I'm getting so many of them. Where's the... Huh. Something got busted. Ah, there it is. Data's back. I don't know. I guess the ESP got in some sort of host state. Oh, that's wonderful. Okay, time to draw a canvas. General canvas example. Okay, I have to process that packet apart. What is the syntax? JavaScript split strings into array. Dot split. Bar equals data dot split tab. Counselor log parse. Boop. CP00. That's not good. But you know, get data.
Hey, Charles.
Uh-huh.
How quickly does the program have to call survive poll?
A lot. A lot. You can probably just put it in a thread by itself. The only reason it's done that way is so that if you can't have, like, if you have synchronization issues with the data that would be coming back from it, that way it like lives in its own place. But
Yeah.
if you need it, if you think you'll be taking time, you're going to have to stick it in something that's going to just fly.
No, I understand. So that needs to run like maybe like 10,000 times a second.
Yeah.
Okay.
If you wait too long, it'll just drop data frames.
Yeah, so survive poll is what's crashing on data recorder for me, not for VicNet. VicNet's not having a problem with that. But what's different between data recorder and calibrate is that in data recorder, the GUI is in its own thread, whereas in calibrate, I think the survive poll is in the thread. So they're set up differently. And that's the exception. I need to see what happens if I switch that around. What happens if I put survive poll in the thread and leave the GUI in the main thread? The data recorder.
The data is coming from this little light sensor down here, right there. Stop moving. Stop. Let's reduce the sensitivity a little bit. Okay. What's noisy? Oh, when I was messing with the mic. Wait, Andrew, can you listen to the stream and see what the noise sounds like?
That's someone tinkering in the kitchen.
Oh, so it's not that you're hearing noise. Oh.
Clicking on the mouse.
I don't think it's the clicking. That's just that.
It was like a quieter, like more regular.
Are you guys? Is it the hiss that you guys are talking about?
It was also this.
Oh, I hear it. I don't know what that's from. That could be EMI from the ESP, I guess. How do I decode a string of hex into numbers? And I think I have a library function for that. Hex. Hex to IP, to hex, hex. JavaScript hex to array of numbers. JavaScript, convert hex to... I think it's parseInt too, I just can't remember how to use it. Wasn't sure if there was a better way to do it for... Oh, I don't want to go the other way. Okay, sure, let's use parseInt.
Alright, I figured out what's wrong. Charles, you're not gonna like what's wrong.
What's wrong?
You're not gonna like it.
What?
You are.
So, both
Talk loud.
survive poll on Mac. Both survive poll, as well as any Objective-C functions having to do with drawing to the window at all, have to be in the main thread, and that's just ridiculous.
I don't believe you.
Well,
Wait, maybe you can launch the GUI from a different thread.
from a
Or launch survive from a different thread.
maybe I can launch it from a different process.
No,
I'll
not
drill
from a
into
different
this and
process.
see
Hold on, look.
which function call with regard to GUI drawing is crashing, but
Hold on, let me show you something.
okay.
No, I want data recorder.c. So if it, where is, oh, okay. So if you look over here, see where it says survive init, survive install function,
Yeah.
survive IMU?
Oh, so if
Call
you do
all of them from a different
all
thread.
of them from a different
Yes.
thread.
Yeah, no, I am aware that with survive on potentially multiple operating systems, all of this must be called from the same place. And I am going to copy and paste Zengvi's code.
I will give that a shot.
Um,
That looks like it. That looks promising. So it might be that they just have to be all called from the same thread,
I think so.
not necessarily the main thread. That would be much, much better if that's true.
I don't actually want to do it that way. What I do want to do is that. By the way, disclaimer, I don't know if you intended to do this, but it's too late now. Any code that you paste into the chat automatically gets licensed under the MIT X11 license. No backsies.
Surprise.
I forgot how to do array. I'm so bad at this. I've encoded JavaScript in like a week, and I've already forgotten how to do arrays in JavaScript. Oh, it's this. Okay, that's what I thought it was. Why no connect? Hello?
Yes, that is correct. You can run all of libsurvive, all of the Vive stuff in a separate thread. Good call.
Good. Oops, sorry. Gotta always aim high enough so you can't see my keyboard for passwords, or low enough so you can't see my keyboard for passwords. Oh yeah. Wait, that's wrong. firmware web page, pushed, refresh, pull. That is not what I wanted to see. Parse, oh, it's parse that length equals 4. Let's try that. Pull. Hex is not defined. That is parse of 3. Let's try that. Pull. Yeah. I think what I actually want to do instead... Do I want to do it that way? No, I want to do it 1 byte at a time. I think it's probably MSB first. So I'm probably going to have to pull off. So if D and 8, if that, eight, 4, 2, 1, and that should hopefully push the right stuff. Take a look at this one. This one looks nice. False, 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 true, 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 false, false. Ooh, that's not good. Let's check this. So if I read this as a human, I see a clump there, and a clump there, and a clump there. So let's see if my code decodes that the way I would expect. So I see a clump here, a clump here, a clump here, clump here, clump here, clump, clump. Okay, so this data is coming through pretty clear. That's good. That's very good. And width. Let's say the canvas width will be, oh, I don't know. It's actually, I've never seen that syntax before. Is that even JavaScript? Oh, yeah, okay, I see. Andrew, did you know in JavaScript if you use a back apostrophe, you can just start writing stuff with new lines and junk and everything until it's seasoned? Or it doesn't matter, it can be any string, I guess. Well, this is just happens to be HTML, and then he just puts another backtick, and that makes it a string. I didn't know that. That's neat. That's a really good way to hide that. I don't need to do it that way anymore. I wonder if those individual byte chunks there are noise or if there's something else going on. I think they're probably noise. Okay, this is good. Happy code. Okay. Let's see if the canvas width is correct. That's not right. How do I get canvas width from jQuery? Cool. So Carlos, just so you know, today this goal of this live stream is to be able to read packets from the lighthouses on an ESP 8266 and somehow pipe that into libsurvive, even if it's not perfect. Canvas raw line example. How do I get the HTML canvas from this?
All right.
Yes, Dave?
Yeah, so basically...
Don't forget to talk loud.
Okay, so in terms of getting the Mac stuff to work, it looks like you have to be religious about putting all of the Vive stuff in a thread and putting all of the GUI-related logic in the main thread. And you just have to break it up. All right, one thread for all Vive, and the main program is the GUI. And Mac's really particular about the Coca stuff, setting up a window. When you create the window has to be in the main thread, and it's really particular about how you can't really put any drawing codes from a thread that access the window, at least from what I'm at Lafine. So it's really kind of silly. I'm not a big fan of Objective-C or all of that stuff, but if you split it up that way, it works perfectly. So now at least I know exactly what's wrong, and the head API stuff is working really well. I don't know why we were running into that one issue where it couldn't find the config data off the Vive, but that seemed to resolve itself. I'm going to go and take another look at compiling that again and see if I run into that issue again, but it seems to be working a lot better now. So at least data recorder is working perfectly, and the calibrate isn't quite broken up perfectly, or at least if that's the definition of perfect, it's not exactly broken up that way. So I'm going to go back and fudge around with calibrate and just get it so that it puts all the survive in a thread and it puts all the GUI in the main thread exactly, and go from there. So it seems like that's pretty much the only OS X incompatibility. Not a problem with Windows or Linux, because OS X, you know, they're gaining market share and deciding to do things their way, I guess. So we all have to comply.
Josh points out that that is how all OpenGL is, that all the commands must be in the same thread.
Yeah, well, it's worse because, yeah, it is using OpenGL, but it's even worse because the Coca commands to actually create the window, because I'm using Coca to create the window, I'm not using Glut. And the Coca commands to create the window also have to be in the same thread. So I can't even, I had tried this a while ago, not even running any OpenGL, just creating a window and not even getting to the point where we make an OpenGL context. It can't do that from a thread, from what I could find before. So I didn't test it today, I tested that a few weeks ago, so that kind of puts your hand behind your back, and I guess, you know, obviously the Vive is the most important, but according to Apple, the window, your GUI window is the most important thing in your program for whatever reason. So there you go.
So Coca needs to be in main always, Josh asks?
From what I was testing before, I mean, I can go back and look at it again, but I tried that before, and as soon as I made any, what is it called? It's not a function call, it's a message or something like that, and as soon as I made an Objective-C message that was GUI related, it crashed. Before it even got anywhere near the OpenGL stuff, so maybe there's a way around that, but and I can't say that I'm the best Objective-C programmer either. There's this beautiful tutorial from Coca with Love, which shows how to create the absolute smallest possible Coca program that opens a window. And if you try to open a window using Xcode, it creates a resource file and it creates all of this other stuff that's really complex, and I can't make heads or tails of how it even calls the first function, since there's so many layers of abstraction, and it doesn't even obviously call a function. It's just compiled to link time code or something to do things. So this Coca with Love tutorial is really, I think, the best way to do it, because it's actually, you know, not to say that Objective-C is legible, because it's not, but you can at least follow one line at a time and see how it actually opens the window, which is, you know, a blessing, I guess. But yeah.
Are you serious? Resizing the canvas is faster? Okay, well, I'm going to resize it anyway, then. Let's just do that. I'll just make it so it's... Whoa. That's not what I was expecting. I would not be amazed if somebody writes disambiguator.js and pose.js either. This is definitely confusing to me. Why does that canvas look so hosed? What is going on? Oh, and it crashed the ESP somehow. Wow. I'm resizing the canvas. It is not working. What am I doing wrong? How do I check the CSS width of the canvas? What would that even look like in C code or in JavaScript code? Is that not right? How do I do it in jQuery since I'm trying to do that? Let's try that. So do I not want to use the jQuery resize function? Yeah, I don't think I want to use the style resize. I think I want to use... Oh, it's the canvas resize. Okay. Nothing. Nothing at all. Oh, something's wrong. Oh. Okay. Is that right number of pixels? I don't believe I do. When I checked the CSS info on it, it didn't say anything. I don't really want to draw the colored bar right now. Sure, I'll fire up the inspector. At least undo this first. Inspector. Why can't I? Hello? Dearest Inspector. Inspect. That, okay. Oh, height equals 100. Yes, Jamie. Yes. The benefits are very clear. And it is very frustrating when somebody gets in the way of those benefits. Well, I don't think I am creating new canvases every time. I think it's just not resizing. I really don't know what's going on here. Let's put this in its own div. Oh, it is in its own div. That looks like the right way to do it. I think I already have it. Sorry, Dominic. Did it crash? Oh, it did crash. That's weird. Yeah, buddy. Oh, that's weird that it makes the not scrollable. Maybe I need to define this thing's width. It gave me a scroll bar, but that's totally not what I want. It did not indicate that. So how do people think I could put this in here and make the div 500 pixels wide? Can you guys like give me a style that you're recommending? Oh, wait, never mind, it just did it. Look at that beautiful wave. That's a lot cleaner than I was expecting. Was it in phase? Let's look at that. That's a good point. Let's check. No, I don't think they're in phase. I think that was just coincidental. Although it's close. Hello? Dearest ESP? No, they're definitely not in phase. That's just coincidental. I mean, they're no, it's totally out of phase. No. That was a really good point, though. If you would have been right, that would have been a really suspicious thing. But this definitely looks out of phase to me. Yeah, it's totally out of phase. I think one of the things I want to do now is I want to filter out for if a packet is only like 1 word of noise long. I think I want to filter it out. So if the flag len is less than, I don't know, 3, then I probably want to switch back to mode 0. And I want to reset it. Otherwise, I want to go make that work. So let's see what happens. Oh, I actually have to reflash. Make that burn. Can I do it remotely now? What is it doing? Hello, ESP. You gotta come back? Oh, it came back. Hey. That's probably not the best way to do it, though. It's a custom file system. It's a little bit like spiffs, but in only so far as how all custom file systems are like spiffs. Like, everything is all the same when it comes to really basic file systems. But the principle is identical, so if you are used to that, then cool. That looks really neat. Make that 4 minimum. No, 3 minimum is probably good. The goal is to turn this into another device that libsurvive can track in 3D space, hopefully.
Alright, great. Calibrate's working perfect.
I just realized something. At any rate, Robert, the goal is to find based on the pulses, to find the angles and then feed the angles into libsurvive. But this is an interesting point. I just realized I don't know if my disambiguator is doing things right for libsurvive now, because I feel like it should be detecting based off of the center of the sweep pulses, but one of the edges of the main sync pulses. I'm worried that that might be a problem. Well, I don't know.
Yeah.
What?
Yeah, that's exactly it.
What is?
And if I move any of the survive logic out of the survive thread.
Oh, okay, go.
So yeah, splitting it up exactly that way seems to be exactly
Explain what way.
Where you put all of this for Mac OS X, putting all of the libsurvive logic into a thread, and putting all of the GUI logic into the main thread, and being very exact about doing that, and just doing it exactly that way seems to be the trick to getting it to work nicely on Mac. And if you start moving some of the survive logic out of the survive thread, then it could potentially on Mac have some issues, whereas if it's all in the same thread, then it seems to be surviving quite happily. So yeah, Calibrate is fixed up to follow that paradigm now. So I'll undo some of my print statements and then push the changes and look and make sure that all of that still works on the other platforms. And
Okay.
Great.
Wow. Let's see, what does this data look like right now? Something is busted.
You want to put the camera back on you?
Sure, but wow, what is going on there? There is some nastiness coming down that line. That is not tied to the lighthouse, I guarantee it. What is that? What? So that's good. What is that? Oh, man. Let's run that again. Oh. Oh, okay. Okay, it's because I'm still outputting that junk. So what I'm actually getting right here is you can see that the junk that I'm outputting on the I2S port is then coupling over with my my setup here. It's coupling over to the other port, which is just absolutely terrifying. So the wire that has the I2S output data on it right here, which is going back that way, is actually coupling with the circuit right here in this. Causing noise on the line, so I'm going to have to disable the actual hardware I2S debugging. Let me do that now. I'm going to remove the ability to output that. And also looking at this, I'm pretty sure 40 megahertz is going to be enough because we'll be able to do some tricks to dither the data. Hopefully to get it more precise. should do us.
60 hertz AC.
That is not what the problem is. My humming does not create that bad of an RF field as far as I'm aware. Okay, let's check it. Okay, and let's scope it. Oh, it's still there. Where is that coming from? Where is all of this noise? What in the world? Oh no. Is that noise coming from the Wi-Fi chip? Oh man. Oh man. Bet you that's coming from the Wi-Fi. No, these modules are actually FCC certified. Like 100% truly FCC certified. That's a decent idea. I could turn off the Wi-Fi. Wi-Fi is now off. Record for a few seconds. Oh no. It's clean now. So let's try this. Let's bump this over here. That over there. I can pull the frame. Okay. It's just nasty. Man. Why don't I get a break? Just can't believe that. We have a ground loop somewhere. No ground loop. See if that shows up. It's interesting that the ground potential changes. Pin 1. Why is it 0.4 volts? That's wrong. That's really wrong. What's going on?
having trouble with Wi-Fi? So that I can push the change.
What kind of trouble?
Is it Charles?
Yeah. Andrew can give you the password.
It's just not loading anything.
This is Wi-Fi.
Well, now we just said my password on
It's not
the
even a
internet.
password, it's just whenever I try to load a page, it just doesn't load.
Well, if you don't get the password in, it won't load.
Yeah, but I was using it before.
Okay. If you need wired, I have wired. Maybe more decoupling. Tell you what. Yeah. No, I don't have any good grounds. Actually, you know what? I do have some good grounds. Let's just dangle them all over the place here. The other thing is I'm not really shielding this, and I could. Let's try that. No, it's still the same. Okay, I don't get this. That's really strange that that pin would be so high. It's like something's just not grounded at all. Wait a minute. Yeah. Well, we certainly have something sad here. So if I hold it close, it doesn't... Okay, is the web page down? No. Wait, now it's perfect. Now everything is perfect. What in the world?
Sounds terrible.
Everything. Look at this signal. It's crystal clear.
It's the worst kind of success.
What's going on? Why is it? I don't get it. Okay, sometimes it crashes. Why does it crash? Oh, I can't even debug it anymore. That's great. I have to Okay, and it stopped the I2S engine then. Okay. I reset it. Okay, let's see if it's still nasty. Well, it's not perfect, but it's not terrible.
Charles, about that Ethernet cable. This thing? Oh, that.
Mm-hmm. It's pretty long. You probably want to feed it underneath the cables that are sitting over there.
Yeah, I'll do it that way.
I think that's probably the buffer, or the buffer that I'm overflowing. So, oh, you know what? How about this? Let's plug it in and see if our noise comes back. Oh, it's not perfect. It's not terrible. Whoops. And it's back. It's back with a vengeance. I didn't actually change the configuration. Let's try this again. I'm going to unplug this. It's still there. Where is this noise coming from? Does the EMI and the audio change when what? I don't see how I could have any loose connections. Everything is fully inserted. I don't get it. It's not perfect, but it's pretty darn good. No, it is perfect. That's just great. What's going on? Look at these wonderful packets. Look at them. What is changing? Let me just ruffle it a little bit. It's still perfect. What is... Oh, no, not perfect. But... Wait, no, it's definitely changing as a function of like where these wires are. Let's try that. No, still noisy. Still noisy. What? Not as noisy. Okay, so maybe... Oh my gosh. This is not looking good. Yeah, I think if so this circuit board here doesn't actually have a backside. It only has the stuff on the front. So I'd imagine if I put a ground plane on and I tightened it up some, it would be better. And other, related things, but this is just absurd. Oh, great. I can't believe it goes away so clearly. It's not gone, but it's like, there's a big Wi-Fi packet. But is that better? Is it making less noise now? Oh, but there, the noise is now affecting the incoming signal. Look at all that trash. Look at all that trash. This. Andrew, can you turn on the mic? Or turn on the sound so I can hear it? I'm going to go... Can you turn it up all the way? Okay, I'm going to move it close. And... can you turn on the mic? Turn on the sound so I can hear it? I'm going to go... Can you turn it up all the way? Okay, I'm going to move it close. Yeah, that's about the right pattern for the noise I'm seeing. Ah. Yeah, that's about the right pattern. Yeah. Because it's doing WebSockets at about 200 hertz. And so that's about that pitch. 300 hertz. Man. Let's see if I can just find some configuration where it's pretty quiet. Yeah, but the thing that cued me in was the higher pitched squeal, which was at about 100 and or around 200 something hertz. Unless somebody out there wants to listen to this and figure out why it's making that particular noise pattern, if you want to record this, I'm just going to put it there for a second. Man, look at that. You put a little screwdriver next to it and it turns into total trash. Wait. Oh, okay, it's still there. I don't have a shield. There is no shield wire going to this thing. I mean, it's probably fine. We can probably just keep going. So currently the ESP... How is it being powered? Oh, yeah, okay. Oh, good call. So the ESP is actually being powered off of that. So by unplugging the programming header, I'm not changing the ground state at all. Good call, James Bowen. What I can do is plug up a battery and run ESP localizer off of a battery. Okay. Now it is operating on battery power. The only ground point is through the Sele. Oh, wow. Yeah, that cleaned it up pretty good. Oh, thank you. Good call, James Bowen. Oh, whoopsies. That was something good. Thank you. Oh, yeah. You know, one thing I'd really like to find out is if there's a synchronous number of pulses per thing. You know what I can do? Let's go code some of this in JavaScript since it's easier to... Oh, okay. So I guess I will explain this because that really was kind of a major thing. So one of the problems that you can get with electronics is called ground loops. And it's when you have something grounded from 2 points and the ground potential can change between them. So in this case, I have plugged in here the power plug for this board and it's hooked up to ground. But this ground is actually hooked up from here into the USB hub. Then the USB hub is hooked into my computer over there. Also hooked up to it is, up the top, is the power plug or USB plug that goes all the way back here to the Sele analyzer. The Sele analyzer is then hooked up to this board through ground. I have some of the grounds on the Sele hooked up to the board. So potentially there could be currents that are involved in that wire that could be causing all sorts of crazy junk, which could cause all sorts of issues. I thought I checked for ground loops to begin with, and I did, because I also had this programmer plugged up. I unplugged the programmer. Unfortunately, I forgot that I also was getting power from the computer, so it was the combination of both things that ended up posing me. Oh, thanks, James Bowen. Say, do you want to join livestream? Okay, so now is the time when we start coding some sort of decoder for this. So we have a whole bunch of bytes. Maybe we should do some things like figure out if it's yeah, it really looks like it, but one of the things I want to try to do is use the fact that we have many iterations to be able to dither this and be able to get a much closer idea of what the frequency is of the pulses, as well as in time the phase of the pulse. If you only have a single pulse, you can only resolve it to 2 times the sampling frequency. Not the sampling frequency over 2, it's 2 times the sampling frequency. But if you have multiple pulses that are on a phase, you can pull some really neat tricks to figure out exactly where they are in time. So what you can do is, say the pulse starts here and ends here and starts here and ends here, I can average those two and be able to resolve it very precisely. It's the same way if you have like a dot or a picture of a dot on a computer, you can, like on a camera, you can figure out where that dot is in 2D space more accurately than you can go beyond a per pixel accuracy is what I'm saying. And so here I should be able to get sub-sample accuracy. If everything works out the way I think it does. The only thing that might kill me on this is the fact that that I have this ringing going on. So it's this kind of unpredictable thing where, like, here it goes wax down first, and then over here, let's see, what does it do this time? Over here it wax down again. Maybe it's really not that big of a deal. Maybe I'll be fine. So here's another example. Here you can see it started to come up, but it didn't go up all the way. So I have it. This is probably the first bit that it actually triggered on, and so it sees all of these. But then there's another problem at the end here, where maybe it sees that, maybe it sees that, maybe it sees that. So I don't necessarily know where this series of ones terminates. So gonna have to figure that one out too. I would imagine this is what Alan Yates was talking about when he was discussing all of the details that go into the analog enveloping that goes on inside of the official Triad semi-chips. I don't really know how to combat that here, other than maybe I might want to widen up my filter some, but that would be kind of tricky to get working. So I'm going to do the best I can with this, with what I have, but it may not be good enough. Still worth me poking around. The other thing is here, I don't necessarily know when I'll start tracking and when I'll stop tracking. So that's what I wanted to talk about there. So let's try to think about these in a meaningful way. And actually, better yet, you know what I'd like to do? If you guys out there on the internet, what I can do is I can start, I'll make a new issue, GitHub, CNLore, libsurvive. I might want to consider a comparator, but I really don't need one, and for the application I'm trying to use this for, I just can't afford a comparator. Like, already, the cost of the components on this board might be too high. Direct sampling to time phase data. Okay, so what I'm going to do is I'm going to make something where I can dump this data out, and you guys out there on the internet can analyze it. So we'll see what I can do there. So what I can do is I can create a new text area. HTML text area. So Dave, how's it going?
I had to pull, and it screwed up the make file, and now I can't get it to compile.
Nobody changed the make file, though.
I made some changes, and that changed them back, but they technically changed things. And then I pulled, and and now I can't compile it. It's having trouble figuring out how to link to the draw function to like swap numbers. Which I know is in cocadriver.n. But when it tries to compile through a data recorder, it includes graphics LOFI. And I don't know why it doesn't just compile in these .c files directly. Why don't I make it do .c files? Draw functions. That makes more sense to me.
I don't know. Make sure to at least, I always keep a copy whenever I do anything that might screw stuff up. I always try to keep a copy around. But right now, you could keep a pristine copy of what's in there, and then try to work based off the pristine copy, unless that's what you're already doing with the checkout.
Oh, I don't know. I don't. You see, I just assumed that I could just push my changes, but now that things are going astray, so I don't know what exactly is causing it to not compile. Or which exactly what's wrong with it. It's a link error.
I believe the peaks in the plot are at 1.8 megahertz. I do not know for sure. If I could bring your stuff up on the main screen, we could talk about it some. If you're interested in doing that. Oh, that looks neat. Andrew, look at this data. Oh, I could hold on. Oh, no, I can't resize it. Oh, I can, okay. When you make it the right size, they all line up.
Yeah, so you're figuring out the period.
Yeah.
Or a multiple period.
Yeah, oh my gosh, the data looks so good. How do you stop text areas from word wrapping? Wrap equals off, okay. Sweet, look at that data. I'm gonna go pull that and paste it in here.
I think there might have been some minor changes to the way the GUI was organized. That's what it was.
There was a while ago, but not since before today.
Yeah, but I think I have to include rasterizer directly.
You should not need rasterizer on a Mac at all.
I shouldn't, but right now I need to.
Well, that's concerning because you should write if you're using OpenGL, you should be able to use the GL functions.
I understand that, but until that's fixed, for the purpose of compiling something that runs right this minute.
Okay. These are some hilarious GitHub issues. Okay, everyone, go have fun with this data. Start figuring out some algorithms we can use to get phase and motion out of it. Oh, that data looks really good. Let's see, if I rotate this around that way, can I pick up data from the other lighthouse, I wonder?
So is there a way that I can mark files merged?
Yes. I don't. Oh, git space add them. Git add the file, and it marks it as merged.
Okay.
Oh my gosh! Yes, look at that. I'm getting data from both lighthouses. I think. I'm pretty sure. Look at that. It's so pretty. So pretty. you can see that the pulse width increases through here, through the middle, where you're in the bulk of the sweep. Oh, yes.
Finally, I pushed it. What you got there?
This is logic analyzer trace of a sweep, and this is how the ESP8266 sees it.
Oh, wow.
It's so clean.
It's seeing all of those.
Look at that.
Yeah? Looks like a perfect square wave.
How much is each bit in the data? What do you mean by that question, Evangi? Zislis. I'm sorry, I can't pronounce your name. I'm curious, what is the... If you were to treat that, what is that? So that's unto... So it's between 23 and 22 bits for 1.8 megahertz. Each bit, I'll add that. So, yeah, I think 40 megahertz is going to be enough now that I'm looking at this data. Data comes in at 40 megahertz. Okay, we'll talk a little more about the data. So what I'm hoping to get out of this is if you see a pulse like this, and say this like rear one is missing, we should be able to look at the pulse widths along here, and some of the pulses, like as it gets longer, you should be able to see kind of a peak of width in the center, and we want to track on to where that peak of width is. Not necessarily where there's like this pulse is in the center or this pulse is in the center, but we may want to latch on to the idea that, well, it's between these two pulses, and somehow use all of the information about this, all of these on and offs, in order to determine that. Something like this here is a pulse at the beginning, like a sync pulse from the tracking station. And so like maybe the fact that this is a really big pulse in the beginning should be something that cues us into saying when it actually started. Or this here, this looks like a pulse from the other lighthouse, the one on the other side of the room. And that's just, I don't know, it's kind of weak, but I would imagine we should be able to get more phase information out of it. My gosh, this data is clear. That lighthouse is like 6 meters away, and it's all coming in. So like this here is a pulse from the lighthouse directly in front of me, a sweep pulse. So I don't know, does that make sense, guys? I guess I'll copy this here into there. We might actually want to end the live streams now, actually. It's getting pretty late. So I mean, I would say we're doing pretty good. We now have a mechanism by which we can look at some of this data and maybe we'll be able to turn it into something useful. So maybe we should discuss in this channel. So finding the center is good. We'll need to know the center. Yeah, actually that's it. All we really need to know is the width, about what the width is, and where the center is. So we actually do need to know both. We need to know approximate width and where the center is. I would be able to tell which lighthouse the data is from. Actually, you know what? I can do that right now. So this is 159 bytes, which is actually, I believe that's... that's actually, it's 159 words. Let me go fix that code in here. So it's 159 words times 32 bits per word. So that's 58. So that's 40. okay, divide that by 40 million. That leaves us 0.01272 times 48 million, and that leaves us of 6105, which, if we go look up NARAL, lighthouse emissions, what we can then see, whoopsies, that's totally not the right thing. What am I clicking on here? OOTX? Wow. Okay, there we go. Oh, nope, that's what I wanted, that link. That would be 6,000, so that would be J3, so that would be skip 1, axis 0. I forgot which one skip means, but I think that that would mean that... It depends on if it was the first or second pulse, so I'd be able to determine which lighthouse it is. But if it says skip 1, it just means that it's not where the pulse is going to come from. 20, I happen to know that this pulse is a sweep pulse from the lighthouse in front of me, because if we calculate the amount of time that the 20 words is, it's 20 times 32, and we divide that by 40 megahertz, and we multiply that by 48 megahertz to get it into the Vive system, and that's 768 ticks. 768 ticks is under 3,000 ticks, and therefore it is a sweep pulse instead of a sync pulse. Sync pulses are what are emitted by the lighthouses when they go flash, and sweep pulses are what happen when the laser sweeps by and whacks this thing. Does that make sense? How's it going, Dave?
So apparently CocoDriver.m was never checked into revision control somehow, so I had to add it.
Okay.
That was a... wow. I mean, there were problems with the Mac, but that's a big one if it's not there.
Okay. Oh, you know what? I'll bet you he was trying to use null driver, and that's why I'm like, I fixed null driver, but you shouldn't be using that. So he was probably using the null driver, and so maybe he changed the code to...
Yeah, the make file was changed to use null driver, and that's why it was in conflict with my make file. So I had to go back and fix the make file, but then I was like, well, let me commit CocoDriver.m. It's like, this file is unknown to Git.
No, we're good.
Checked in.
Sync pulses are long. Yes, Jamie Christie, that is exactly right. You totally nailed that one on the head. I think in order to do this processing fast enough in C, I'm going to have to use some sort of table-based approach. I think I can process nibbles at a time. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And for each nibble, I could increment something. I don't know. It's going to be kind of hard to process that fast enough. James Brown, the grounding issue did get solved. It was because of a ground loop and the way I was powering the ESP 8266. Oh my gosh, all of these packets look so clean. Oh. Actually, you know what? I could get you guys a ton of data real fast. What I can do is I can say... Okay, we'll use this. Actually, you know what? This is kind of stupid. I'm going to put this in a file and attach the file. Actually, you know what? I'll just get a couple more, because who doesn't want more data? Yeah, buddy! To think just about an hour ago, I figured I'd have to give up on this. Okay. So even if you store the length of each sequence, you can probably find out the max 1 or 2 min points. Yeah, that would work too. If I don't have enough processing power, it turns out. We'll see how that goes. I might have enough processing power to do it all. I don't know. This has been a lot of fun. I got a pretty long ways. Git add user lighthouse decode.c h git diff. Okay, that looks about right. Wait, what's all that? Yeah, okay. Git commit dot. Doesn't look like there's anything missing. Update z code to interaction. Okay, and this is in the ESP8266 Lighthouse firmware. I just realized I opened this in the libsurvive issue, but I will link it. Yeah, you will need the estimation. Well, we don't currently estimate Z with libsurvive, but I really do want to use that to estimate distance. Dave, do you have it?
Oh, Z estimate.
No, I meant for your stuff. But if you're interested, they point out that you might be able to use this information. Where is it? The pulse width information.
Pulse width information.
Here, I'll open up the file again.
Okay.
So in here, under lightpulses.txt, some of these pulses are very, very small. Like, notice how that's only 3 bits on and most of them are off. And you may be able to use that in order to help estimate the Z distance from the lighthouse sensor.
Okay, so that would probably be inversely proportional, right?
Yeah.
Yeah, that would help. I mean, you know, I guess we have a bunch of posers now. The way mine was doing it was that it assumed an orthogonal projection and basically used the distance and also the it just made a linear transformation, a 2x3 matrix, and use that to estimate the distance. But if we have an initial guess, especially since some of the solvers are it looked like they were doing some sort of gradient descent. So if you have an initial Z distance, I would think that would help improve the gradient descent if you could start someplace closer to the solution. So yeah, I think that would be good information. I wouldn't want to throw that away because we don't know if we're going to need that. So
okay,
it certainly can't hurt to have it. It's a good hint.
So the goal will be is take this data, figure out the start time, the center of the data, and the I don't know, what would you call it? Center of the data and the strength of the signal is. And actually, you know what, while we're here, I'm probably going to do something else. Maybe not right now, actually. I might make it so that every single pulse that comes in, it also transmits out as a UDP packet onto the network, so we can play with that. I don't really have anything else to do right now other than like digging through this and getting into some more of the dirty stuff with OSX and whatnot. Is there anything else we should do live, or you guys pretty much good to go too? Just I guess chat and chat if you want to talk about anything else, or if we can just call it over. That would be okay with me. What is the stream time? Does anyone have that? I guess 6:30 to 10 something. As long as, oh, here it is, 3 hours 41 minutes. So we have up to 20 minutes left before YouTube makes it impossible to edit. I don't want to say impossible, but a pain. I guess I'll play an ad and then. Okay. I don't see any more people chatting, so I guess it's just 51 people who left their browsers open. Well, let's see. Closing that. I wish I could have a thing so other people could hit play ad, like whenever I leave the camera, so we can just. When it comes to learning about electronics, you just start small with like an Arduino and making it blink, and then you start interfacing with more hardware and figure out how to move a servo, and then you start, I don't know, you just start small and you just keep going. And you just keep going, and you don't stop, and you stay up at night until all of the projects that you wanted to complete are done. That's how you do it. You just keep going. Okay. I think we're going to call it quits. This has been pretty good. I'm really glad that we got data and we have a little interface in the web and everything else.
And we fixed Mac.
And we fixed Mac.
Wait, no.
Well, we almost fixed Mac. Okay.
Okay, it sort of fixes the Mac.
Mac is sort of fixed. Let's just stick with it.
It's fixed on my computer. VicNet is still having a few issues, but it looks like it's mostly working.
Okay.
Happy Mother's Day, everyone.
Oh yeah, happy Mother's Day. Bye. Next live stream, no plans right now because Magstock is going to be the weekend of June 8th through the 11th, and I co-chair Magstock, so I will definitely not be live streaming before then. Maybe after then. In the meantime, though, you can always hop on Discord. Okay. It could be sync 1, sync 2. Yeah, it's one of 6. Yes, you're correct. Each recorded pulse wave could represent one of those 6 things. Don't try to figure out which one of the pulses it is, though, because who knows? It could be either one. I didn't carefully track that. Okay. Goodbye, everyone.